Hello students, today's agenda is to check homework. We'll be learning variation and standard deviation, and you will be able to do 12.2. Today students will be able to calculate variation and standard deviation as measure of dispersion in a data set. In here we have two questions, and we chose possible answers at random, but we set it up so that you can compare this information in relation to the variance and the standard deviation. So now the first thing that we're going to do is just apply what we learned in the previous lesson for the mean, average. What you do is add all the items and then divide by the number of items in the data set. So how many books do you have in your backpack? These were the answers. If we add that, is 12, 14, 19, 20, 23, 30, 32, 40. Notice how I skipped the zeros. If you add whatever you have here plus 0, you just stay with that same number, okay? So it doesn't add any value here, but when we divide, we do have to have those into consideration. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to divide by 10, and that will give us the mean average. 40 divided by 10 is 4. That's for the first question. The second question says, how many pens do you have? Again, these are possible answers. And yes, these are made up so that you can understand what we will be working with here. So 2 plus 5, 7, plus 5, 12, 18, 22, 27, 30, 35, 37, 40. So again, we got 40. And divided by, again, it's 10 items. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We divide and we have 4. Okay, so for both of them, we on purpose made it for the mean to be 4, and I'll show you why. So now what we're going to do is that we're going to graph the data just as we did in the previous lessons, where we have a number line, and then for number 1, what we'll do is just put a little cross on top of each number. So we have 12, 2, 5, 1, 0, 3, 7, 0, 2, 8. And so those are the data set being graphed. And as you can see, the data is spread from 0 all the way to 12. Now, what about for the second one? I'm going to graph it here. You can already see that the line is shorter, but you have 2, 5, 5, 6, 4, 5, 3, 5, 2, 3. Here what we're going to analyze is how the two data sets are spread. So the mean for both of them is 4, so the mean is right here. And for this one is right here. Okay, so both are at 4, but notice how from that, how the data set is spread. So it's in here, we can say that it's squished. The data set is squeezing. While in the first one, we can see that it's a little bit more spread out, okay, or stretching. So if we were to describe this information, we can say both graphs, both have the same mean. However, another piece of information is that, the mean. The second thing that we can observe is that in the first graph, the data is more dispersed, while the second graph, they're more closer together. That's one thing. Also, each data set is farther away from the mean, and in here each data in the set is closer to the mean. I don't know if that makes sense, but so graph 1, you can put here, graph 1 is more dispersed than graph 2, and that each data is farther away from the mean average. Okay. Okay, and now that we observe this, there are different ways to measure that dispersion. One of them is to find the range, which means biggest minus smallest. And if we look at that for the first graph, the biggest number is 12. So for number 1, the biggest is 12 minus the smallest one is 0. So that's going to be equals to 12 spaces. That means that my data is taking up 12 spaces. For the second one, the biggest number is 6. The smallest one is 2. And that means we subtract and we get 4, which means that there are 4 spaces between the smallest and the biggest. So that's how close they are. Okay, so that's to show dispersion. Another way to show dispersion is the variance. And the definition for variance is represented by sigma squared, which is when we add the difference between each number in the data set and the mean raised to the second power, and then divided by the number of items in the data set. So to me, it's a lengthy definition. These are the same thing. It's just broken into steps, and usually you take the first 2 steps together when you're trying to find the variance. So the first step is to subtract each number in the data set minus the mean. Then you're going to square that difference, right? Difference means subtraction. So you're going to square each one of those. Then you're going to add the results. And finally, you divide by the number of items in the data set. And so we're going to take these steps, and I think it's going to make more sense once we start. So when you're writing it, you're going to put, for example, in here for number 1, we know that the mean is 4, right? Because we found that at the beginning. For both, actually, it's 4. We did it on purpose so that you can compare this information. And so what you're going to write is sigma square is equals to, it says subtract each number in the data set minus the mean. So it refers to these numbers. And so it's going to be 12 minus 4, which is the mean, and then square it. Okay, that's what it says for the second part. Square the difference, square the subtraction. And so the third one says add all the results. So we're going to put it in here all together. And we do that the same thing for the second. So the second number in the set is 2 minus the mean is 4. Square that, plus 5 minus 4 squared. So the second number will always be minus 4 because you're just subtracting the mean. Okay, and so the next one is 1 minus 4 squared plus 0 minus 4 squared. The next one is 3. So plus 3 minus 4 squared plus 7 minus 4 squared plus 0 minus 4 squared plus 2 minus 4 square, and finally plus 8 minus 4 square. And we're going to write it like this. Again, in here you already have subtract each item from in the data set minus the mean. Square the difference, that's by putting the squares in there. It just means to the second power. Add all the results, that's the pluses in the middle. And then divide by the number of items in the data set. So after you do all of this, you're going to divide by the number of items, which is the 10 items in here. Okay, divide by 10. And so basically you in here, by writing all this, you already have all those steps written down, but it's not simplified. Now we're going to simplify it by doing some steps at a time, following PEMDAS. First, whatever is inside the parentheses, 12 minus 4. And I'm going to do the two steps together. I'm going to be doing the parentheses and then squaring it already. Okay, so 12 minus 4 is 8. 8 squared is 64. It means 8 times 8. 2 minus 4 is negative 2. Negative 2 times negative 2 is positive 4. 5 minus 4 is 1. 1 times 1 is 1. 1 minus 4 is negative 3. Negative 3 times negative 3. Negative times negative becomes positive 9. Plus 0 minus 4 is negative 4 times negative 4 is 16. 3 minus 4 is 1. 1 times 1 is 1. 7 times 4 is 3. 3 times 3 is 9. 0 minus 4 is negative 4. Negative 4 times negative 4 is 16. 2 times negative 4, no, 2 minus 4 is negative 2. Negative 2 times negative 2 is positive 4. 8 minus 4 is 4. 4 times 4 is 16. And then all of these divided by 10. Now that they're not in different lines, I can just put all divided by 10. Add them in here, 64 plus 4 plus 1. You do it on your own so that that gives us 140 divided by 10. You know that this can cancel in division, so 14 divided by 1 is just 14. So that's going to be about how spread our data is. And as you saw, it actually goes from 0 to 12, so it's about 12 spaces. So this is an approximation and a different way to measure how dispersed the data is. Now let's do that for number 2. Do the same thing where you subtract each data set minus the mean, square that, and then you add the results and divide by the number of items. So for number 2, I'm just gonna start, and then sigma square is equals to 2 minus 4 square plus, and out of the other ones, okay? Plus 3 minus 4 squared, and all of that, we know that that's the whole thing, right? Divided by 10, because it's 10 items. Okay, so this is how it should look. Now for the next step, again, I'm going to subtract each one and then square that and write the number here. So 2 minus 4 is negative 2. Negative 2 times negative 2 is positive 4. And so now do the rest, okay? Six minus 4, 2. 2 square. 2 times 2 is 4. In here we have 4 minus 4 is 0. 0 times 0 is 0. So I just put 0 in there. Okay, I wanted to include that in the explanation. Oh, and the other thing is here, I just put it here, but 5 minus 4 is 1. And the previous one was 3 minus 4 is negative 1. Negative 1 squared is negative 1 times negative 1, so it's positive 1. Same here, positive 1, right? 5 minus 4 is 1. 1 times 1 is 1 also. And so now I subtracted and squared it, and all divided by 10. I think we can do this one mentally. 4, 5, 6, 10, 11, 12, 13, 17, 18. 18 divided by 10, because there are 10 items. When we divide by 10, it's just going the number of zeros backwards. So it's only 1 0, 1 space back. So it's 1.8. Or if you want to use your calculator, 18 divided by 10 is 1.8. Okay, again, this is a different way of measuring how dispersed the data is, and it says that it's about 1.8 spaces for the second data set. A third way of measuring dispersion is standard deviation. It's represented by sigma, and I'll give you the formulas at the end, but I want you to know where they come from. What is standard deviation? It is the square root of the variance. So we just found, all we have to do is take the square root of that variance, and it tells us how far away on average each number is from the mean. Okay, and it also helps us that if the data set is spread evenly, then we can see they say that certain percentages fall within 1 standard deviation or 2 standard deviations because it's spread in a normal set. But it says something about that if we have data, then there is the average for the data set and certain amounts, 1 standard deviation and 1 standard deviation to the right and to the left of that mean, right, from the mean. And then there are 2 standards deviation, etc., etc. Again, more explanation in a different video, but that's just so that you understand what this is helpful for. Okay, so in here, this will be the mean, and then in here you have 1 standard deviation, 2 standard deviation, etc. For now, we're just going to find what the standard deviation for our data set is. So that's the variance, right? This is the variance. Which tells us how spread the data is, but the standard deviation, or sigma, this is sigma squared. Well, it makes sense. You take the square root of that to find just sigma, right? So sigma will be the square root of 14. And so 14, take the square root of that. Our sigma is equals to, 3.7. So that means that on average, each number set is 3.7 spaces away from 4. Okay, and for here, for this one, we also take the square root. That's sigma squared, meaning the variance. So sigma alone, or standard deviation, is again 1.8. Take the square root of that, and you get 1.3. Okay, so each one of these ones is about on average 3.7 spaces away from 4, which is the mean. And for this ones, it's only 1.3 spaces away from the mean, meaning that's how far each one on average is from that mean, from that center. So now that you have all this, we will finalize with the formula. So now let me show you the formulas for sigma square, which is the variance. It's sigma square is equals to sigma, this is lowercase and this is uppercase, times x minus x with this little line on top, close the parenthesis, square, and then divided by n. What does that mean? The capital sigma, or let me just put it directly in here. This is used to represent sum, which represents all those additions. And I'm sorry, this is not multiplication. What it means is the sum of whatever you're doing, okay? It's representing the sum of what is inside. Well, in here, it represents the number, each number in the data set, each number in the data set, if you can write that. This represents the mean average of that data set, mean average. And of course, you know that the square is means to the second power divided by, this is the number of items in the number set. So basically, this formula represents what we're doing here. The addition of the difference squared, each difference is squared, and then divided by the number of items. That's this same thing, okay? If we just want to find sigma, meaning the standard deviation, all you have to do is this, but you take the square root. And it makes sense because if you want to leave sigma, again lowercase sigma, by itself without the square, you take the square root, then you have to do the same thing on the other side, right? So by taking the square root, the square root cancels the square. Now you only have sigma, and that means that if you take the square root on one side, you have to do it on the other side, and then you end up with this, the sum of all the differences of the number in each number in the number set minus the mean squared and divided by the number of items. Okay, so what's the difference in here? This doesn't have the square root. Then for sigma or the standard deviation, you have to take the square root, which is the last step we did for each set. So this is standard deviation. I think it's easier to understand the formulas when you actually do all the process and then, oh, that's the addition of all the differences. The differences are squared and then divided by, once you add them, divided by the number of items, which is what we did. Finally, to find the standard deviation, we just took the square root, right? We took the square root of the variance and we found the standard deviation. Same here. That's the variance, which is represented by sigma square. But in here, the standard deviation, you just took the square root of that. Okay, to get sigma, or the standard deviation, which is 3.7. Okay, with these formulas, I leave you. Please, if you can just give us a thumbs up, subscribe around here. Here's going to be the playlist for the entire unit, and here will be the next video. Now you're able to do 12.2 and have fun.